We are good.
I'm also good. All right. Today we are just going to wrap up the topic of function, of which we have covered 4 different functions. So the first function we have done in detail is what is called the parabola function. And then the second function we have done is what is called the straight line function. And then function number 3 is exponential function. And then the last one we have covered is what is called a logarithm. But the last time I told you that we still have a trig function, which is outstanding, and a cubic function, which is outstanding. So these functions we are going to cover at a later stage, because this function is under trigonometry, and then this other function, cubic function, is under what is called calculus. It's under a chapter of calculus. So we can't do this before covering the chapters for trigonometry and the chapter for calculus. So we'll do those at later stage. So at the moment, let's just focus on questions for the 3 functions I've done with you the previous time, of which I believe you remember the formulas for all these functions, every information about the intercepts, of how you find the turning points, of how you find the inverse and the shifting to the left, to the right, shifting upwards and downwards. All those transformations you must remember, because they are applied in all this, even though some of the transformation we covered as according to the section, but the application of the transformation, you may find that you will need to use in all these 4 functions we have covered. So now let's do the questions that I sent you on WhatsApp. So we'll start with question number 5, of which is about finding the domain and then the asymptote of that given function. But the domain and the range issue, I will explain in detail on the trigonometry. It's just fortunate that we have that question of the domain here, but we're gonna do the domain and the range, the amplitude, and any other thing that relates to that on the trig functions. So in the meantime, let's focus on the domain for this kind of function. I also did the hyperbola function, We also covered the hyperbola. We have done 5 of them. So this question is on the, so we'll have to check what kind of function is that. So we are given a function f, which is equal to -1 over x minus 1. Can any one of you tell me what kind of function is that? Which function is this one? This function here. What is it? Is it parabola, straight line, hyperbola, exponential, or logarithm?
Isn't it hyperbola?
Yes, it's hyperbola, because hyperbola is given by this formula of a divided by x minus p plus q, where p, q represent the asymptote, and then this a represents it tells you on which quadrants we have our parabola function. So I will remind you when we do the question. So now from here, I believe you can be able to see that the value of a is -1. What is the value of p?
Isn't it 1?
It's 1, positive 1. And then the value of Q,
There's no value for Q.
yes. If it is not there, what does that mean?
It's 0.
Means Q is equal to 0, right? So that is just the interpretation of this function that is given there. So it's having asymptote at x equal to 1 and y equal to 0. Then you must know about that. So now let's discuss about the domain of this. So let me give you a definition of a just simple definition of the domain and range. So whenever you come across these two definition, so domain is the x values. So it means you must check the x values of that given function, and then the range are the y values. These are the y values. So let's check what are the x values of this function f. So the x values of the function f, they don't change. Whenever you come across a parabola function, you must know that the domain for the parabola function is given as x is the element of real number, which stands for any number that belongs to real number. But this function, it have restrictions. So the restriction is the asymptote. So is x being the element of real number, but x in this case must not be equal to 1. Why x must not be equal to 1 in this case? Is there anyone who can explain why we say x must not be equal to 1 in that scenario? Because if x is equal to 1, what happens to this function?
It becomes undefined.
It becomes undefined. That's the reason. That's why we give this restriction. So the domain does not change for the hyperbola specifically. So x is the element of real number, but you must give it a restriction. Restriction is the asymptote on the y asymptote, on the x asymptote, sorry. It's the restriction on the x asymptote. So x must not be equal to 1, because you can see if x is equal to 1, this will be undefined. So because the denominator will be equal to 0. So I believe you get that right. So if we were to answer this other question for the range, so it means we're going to say y must be the element of real number, but y must not be equal to the value that is given here, of which in this case is 0. So that is how you define the range and the domain for the parabola, for the hyperbola. But I'm going to give this detail about the domain and range when we do the trig functions, because this domain and range is where it belongs. It belongs to the trig functions. We'll do more on that at a later stage. So otherwise, let's go to question number 2. The question number 1, it was about a domain of which you write x is the element of real number, but x must not be equal to 1, because if it is equal to 1, it's going to be undefined. And on the second question, we are to write the asymptote, write down the asymptote of f. So how do we find the asymptote of this function that we have here? So the asymptote, we have discussed about them. So can you tell me the asymptote along the x direction? X must be equal to, it's 1, right? X must be equal to 1. That is the asymptote on the x direction. And then on the y direction, the asymptote, it must be equal to what?
Isn't it 0?
It's 0. Yes. It's 0. These are the asymptotes of this function that is given there. So asymptotes is given by P and Q. So x must be equal to 1 and y must be equal to 0. So in some cases, they may not say write down the asymptotes. They may say write the equations. So these are the equations that we have here. These are the equations of asymptote. So you must take note of that. It's another important statement which you must take note of. So if they say asymptote of, equation of asymptotes, they mean exactly the same thing that we have here. So x must be equal to 1 is this one here, and y must be equal to 0, the 0 that we don't have there. Are we all together?
Yes.
Can we go to the next question, which is about sketching?
Mm.
Let's sketch the functions. So previous time I told you what information are you supposed to have in order to sketch the graph. I told you the very first information which you must get is the asymptotes, of which we are fortunate we have. And this second information I told you about, of which you must look for before you plot the graph, I'm going to tell you that is this value of A. If A is negative, you know the quadrants where you're supposed to plot the function. Can any one of you tell me the quadrants where we're supposed to plot our function based on the fact that the value of A is -1? On which quadrants are we supposed to plot the function?
Mm.
2 and 4.
Yes, it's 2 and 4. Yes, that's very, very true. We're supposed to plot our function on quadrant number 2 and quadrant number 4 because A is negative in this case. And this last information which we have to find before we plot the graph, which information did I told you to get before you plot the function?
Intercept.
Is the intercepts, the X and Y intercept. Once you have those three information, I can tell you without any hesitation that even a single day you will never fail to plot the hyperbola graph. Those are the three critical informations you must find. So now we have the value of A, we have the asymptotes, we are only left to find the X and Y intercepts, of which we can start with X intercept. We know at X intercept, Y is equal to what?
0.
Y is equal to 0, but Y in this case is the main function f of X. So therefore Y is f of X, which is equal to 0. And you substitute there. So when you substitute there, you could see that in this case, we're going to have 0 equal to -1 divided by X minus 1. So now, this is the scenario we were talking about the previous time. You can't be able to find the value of X here. Why you can't be able to find the values of X? Because at Y equal to 0 is at the what? At Y equal to 0 at the
Asymptote.
is at the asymptote. So that's why when you try to find the value of X here, see what happens. Because we can cross multiply and we have 0 into X minus 1 equal to -1. 0 multiplied by this is going to kill the value of X and it disappears. You end up having a situation wherein 0 is equal to -1. And this is not true in real life. You can't have 0 which is equal to -1. So hence, we must follow the issue of asymptote here. So at Y equal to 0 is at the asymptote. We can't draw any function there. Is that okay?
Yes.
All right. So now we go to the y-intercept, of which we know at y-intercept X is equal to 0. It's a given. You must not forget this. So this value of 0 here, you must then substitute to the main function. So if you substitute that to the main function, you are going to obtain the value of y, of which is the same as f at 0 equal to -1 divided by 0 minus 1. This is the same as -1 divided by -1, and the answer of that is 1. Therefore, you can write it in terms of coordinate. So we now have 0 is to 1 as a coordinate or a point on the function that we have up there. So now we are at liberty to draw our function. We are at liberty to draw our function. So the very first thing we can draw in this case are the asymptotes. So let's start with the first asymptote, which is at X equal to 1. So we can have our asymptote at this point, X equal to 1. Where is another asymptote? There must be 2 for hyperbola function. I have the asymptote at x equal to 1. Where am I supposed to draw another asymptote here? We have to draw another asymptote at what? At x equal to, at the x-axis. Do you see that? It's exactly on top of this line of x-axis. Are we all together? Are we together?
Yes. Yes.
All right. Then after having that, you then plot these coordinates we find in this question. So we have a coordinate or a point of 0:1. So you can have it somewhere there. So already this value of -1, it directed us on which quadrant we're supposed to draw a function. It have to be first and fourth, second and fourth quadrant based on these new quadrants we get from the asymptotes. So we are going to have it here. And then the other one, it have to be there. You don't even need to have any points to draw this graph. So the value of A directs you on the quadrant where you're supposed to draw your function. So it's this quadrant and that quadrant. And that is all that is required here. Once you have this, you are going to get full marks, just free full marks, of which this question comes with 3 or 4 marks. So you must not get this, you must not lose these marks because they're just free marks for you. Can we go to the next question? Unfortunately, question number 4, it's having a gradient of which we haven't done calculuses yet, but I'm going to change it a bit so that I explain this issue of reflections. So let's say we have x multiplied by, we are looking for values of x. We are looking for values of x where when you multiply x and f of x, you are going to have this product to be positive. There are 2 scenarios where you can multiply 2 values and you then get a positive outcome. So the first scenario is when you have 2 negatives. So when you have 2 negatives, you multiply negative, it gives you positive. The second scenario is when both are positive. You have positive multiplied by positive, and it gives you positive. These are the 2 scenarios where we can have this greater or equal to scenario. So we are looking for the domain of x, where when you multiply the values of x with the function itself, you must have a positive outcome, or you must have results where this product is greater or equal to 0. So now let me explain this to you so that you understand what is required on this question. So let's start by looking for a region where x is positive and another region when x is negative. We can first focus on this region where x is positive and where where x is negative and where f is negative. Let's check this region first, and then from there we're going to check the other region. So you must understand this part because it's very important. The interpretation of the graph is what we are doing now. The product where x multiplied by f is greater or equal to 0. Let's start by looking for a region where x is negative. We know x will be negative from this point of origin going backwards. It's where our graph is negative. From the origin going backwards, it's where the value of x is negative. Is that okay?
Yes.
All right. So now let's check. When x is negative on this region, is the graph y negative or positive? When x is negative, we said x is negative on this region. When x is negative, is the graph of f negative or positive? It can be negative if it is below the x-axis, and it can be positive if it is above x-axis. So in this case, when x is negative, is this graph of f negative or it's positive? I'm interested to find out if you know if the graph of f is positive or negative from this region going backwards. Is the graph of f negative or positive?
Won't it be positive because a positive graph is the first and the third quadrant?
Yes, exactly. The graph of f is positive in this case. Why is positive? Because it's above the x-axis. It's on top of the x-axis. Let's say maybe this graph goes like this and it's on this region. Therefore, it was going to be negative because it will be below the x-axis. But now it's not below the x-axis, but it's above the x-axis. So therefore, it means our graph is positive from the origin going to the negative infinity. So it's positive, but the x-axis is negative. Therefore, that is not the region we are interested to. So this region is out. So now let's focus on this region here. From this point going to the infinity. So from this point going to the infinity, is the value of x positive or negative? From here going to infinity, is the value of x positive or negative?
Positive.
Is positive, yes. So when x is positive, is the graph of f positive or negative? When x is positive here, is our graph here, the graph of f, is it positive or negative? I know I'm now teaching difficult thing. I know about that. So don't worry much about this. That's why I'm trying to emphasize a lot, because I know this is one of the difficult things of which if you understand, you'll be fine. So now tell me, when x is positive here, we know x is positive from here going to the positive infinity. So when x is positive, it's our graph is this one. Is our graph positive or is it negative?
Isn't it positive?
Is this graph positive or negative on this region? Let's check here on this region. Is the graph of f positive or negative from here to there?
So you just cut. What did you say?
All right. Let me explain again. So I'm asking if on this region here, from 0 up to 1, is the graph of f positive or negative?
Isn't it positive?
Why do we say it's positive?
Because it's going up.
Because,
I don't know. Yeah.
because it's above the x-axis. We say this graph is positive because it's above the x-axis, right?
Yes.
Yes, this is our x-axis. So if our graph is below, like in this region, this graph is negative. Why do we say it's negative? Because it's below, it's down, downside of the x-axis. Do you see that?
Yes.
Yes.
Sir,
Yes.
do we check the asymptotes or the real x-axis and y-axis?
You check the real x-axis and the real y-axis.
Okay.
Yeah, but in this case, we are just looking for the whole region where the graph of f is positive and where the x-axis is positive. I know you understand the region where x is positive. The problem is to identify the region where the graph of f is positive. So now let me explain this again, because once you get it right, I know you are not going to fail to get this right again. So f of x, the graph of f of x is positive when it's above the x-axis. I believe you understood that statement right. The graph of f, it will be positive if it is above the x-axis. So now tell me, from 0 to negative infinity, is the graph of f negative or positive?
It's positive
Why do we say it's positive?
because it's still above the x-axis.
Still above the x-axis, as simple as that. And then now let's check. We are done with the region of the negatives, because we know on the region of the negatives, while axis is negative, the graph of f is positive. So it's not the region we are interested to. Then let's focus on the other region here. The other region is from 0 to 1. Why do we end at 1? Because after 1, the graph changes. We are no longer dealing with this graph. We are going to the other graph. Because this graph, it ends here. And then from after 1, then we pick up on this other graph that we have done there. So now, between 0 to 1, is the graph of f positive or negative?
It's positive.
Why is positive?
It's
Because
above the x-axis.
above the x-axis. I think you are now getting the point. So when x is positive here, even the function is positive, of which is the region we're interested to. So to answer that question, which say, find the value of x, find x where the product of x multiplied by f of x is greater or equal to 0. I explained here that we're looking for the region where both functions are negatives, or where both functions are positive. And we now identified the region where the axis is positive and the graph of f is positive. So therefore you can write the domain or the answer for that question as x is the element from 0 to 1. And you use the curly brackets here. On the 1, you use the curly bracket, but on the x, you can use the square brackets to indicate the square bracket. It indicates that the 0 is included here on this region. So the 0 is part of the solution that we're looking for. But 1, this value of 1, which is on top of this line, is not included. Why is not included? Because the function f does not touch the what? The asymptote. Hence, you need to use the curly bracket. There's difference between the square brackets and the curly bracket. Are we together?
Yes.
Yes.
I'm explaining very, very important thing. That's why I'm just repeating time and again. I just want this to sink into your head, because once you get this right, you are not going to have any problem with this, even a single thing. So we identify a region that we're looking for. It's from 0 to 1. 0 is included, but 1 is not included. That's why here we use curly bracket and then we use square bracket. And then when we look for this other region here, you can see x is positive in this case. X is positive, but is our graph positive or negative from 1 up to positive infinity? Is the graph negative?
It's negative.
It's negative. Why is negative?
It's below the x-axis.
You get me? So I'm happy because you were able to get this right. That is what is needed. You no longer have to get these questions wrong. Sometimes you may find that they are just multiplying the two functions. Let's say they are looking for the product of g and f, which is less than 0. So it means if it is less than 0, one of these functions must be negative. One function must be negative and then the other one must be positive, because that's when we find the product of this is going to give us a negative. So we must look for a region where the product of these two functions are negative. So you are looking for a region where other function is positive and where other function is negative. So we'll deal with these functions when we get there. In this case, we're fortunate because we come across this question here on question number 2. And I think I emphasized this. We'll do it again when we do calculus, because these kind of questions, they appear very often under cubic functions. So let's just hold on this question D, and we then move forward to other questions. So we are done with question number D. This is the answer for question number D. X is the element from 0 to 1, where we use square bracket here and a curly bracket there. So we are done with these questions. Let's quickly rush to the second questions I gave you, of which is question number 4. If this meeting ends, make sure you rejoin the meeting using the same link. We still have about 30 minutes. And these other 30 minutes, I'm going to use it to explain question number 4. Can I rub what you have on the board?
Yes.
All right. So this question, it says, in the diagram below, the graph of f of x is equal to ax squared. Can any one of you tell me what kind of function is that?
Exponential.
We must be careful
Exponential.
here. It looks like an exponential graph, but it's not exponential. It's what? It's a parabola graph. So exponential, it must have a base of a. And this one is not having a base of a, it's having a base of x. So it means it's not exponential, but it's parabola. Ne? Exponential is like this. F of x is equal to a to the power of x. That is exponential. It's having a base of a number. But here we are not having a base of a number. We have a variable of which is x. Is it okay? Are we together?
Yes.
All right, wonderful. So we are given that function f, which is parabola and is drawn on the interval x less or equal to 0. It means it's drawn on the negative intervals. The graph of inverse of f, you know how to find inverse now, is also drawn. There are two graphs, is the f and the inverse of f is also drawn, where p is a point on f and r is a point on inverse of f. Let me draw this graph and we explain the information that is given there. So we have this graph here and that other graph like this, where this is point R and this is point P, given as -6 is to -12. And this is the graph of f, this is the graph of inverse of f. This is 0.0. We are told that the graphs are drawn when x is less or equal to 0. It means it's on the negative domain, from here going to the negative infinity. Now, the first function, it requires us to check if the inverse of f is a function or not. And we need to motivate why it's a function. Today, I'm going to show you how we prove that what we are given there is a function or not. So we are checking for the inverse of f. Is this function, is this line here inverse, is the f inverse of f a function or not? And we also need to motivate if it is a function or not. Let me shade it before I explain it. Is this function that we are talking about here? We want to prove if this line is a function or not. So what you're supposed to do in order to prove that it's a function or not, you must have your ruler. Myself, I'm going to use a marker. So you must use something that is straight. You can use your ruler if you are in exam rule. And then that ruler, you put it parallel to the to the y-axis. At all time, it must be parallel to y-axis. So it must go straight like this. For sure, it would cover the whole region from here going downwards. If you are using a ruler, myself, I'm using a marker, it's very small. So this marker, when you push it down, how many times is it gonna cross the inverse function or the inverse of f? How many times is it gonna cross this this graph of f? How many times? Let me draw it on the board so that you see. Let's just assume this is a rule which is parallel to y-axis. How many times does it touch this inverse graph of f?
1.
It just touches 1. Whenever you come across this situation, this is the only method you must use. Just use your ruler. If it crosses once, therefore that tells you that indeed this is a function. A function, it must cut just once. So that is a function, and the reason you can say this is 1-to-1. Why you call it 1-to-1? Because it cut one value of x here, and when it cuts one value of x, it gives just one output. That's why we say it's 1-to-1. Let me give a different function which is not 1-to-1. You see a function like this. If you have something like that, this is not a function. Why? Because if you draw a straight line like that, how many times does this line cut this graph?
2 times.
How many times?
2. Hello,
Are we together?
can you hear me?
No, I did not hear you. What did you say?
I said it cuts twice.
It cut twice. Yes, very true. It cuts here and cut there. So it means in this case it's 1-to-many, and 1-to-many is not a function. So it can be a function if it is 1-to-many, or if it is many-to-1. There are 2 scenarios where we can say it's a function. It's either when it is 1-to-many, or 1-to-1, or when it is many-to-1. Otherwise, if it is 1-to-many or it's many-to-many, therefore it's not a function. Did you get me right on that one?
Yes.
I don't get the one for many to 1.
All right. For many-to-1, it's a parabola graph. Let me check. All right, we're testing this graph for many-to-1. So let's